Okay, let's visualize this situation. So I've already plotted points X, Y, and Z, and we know that the epicenter of the earthquake was 5 units from X. So that means it falls along a circle that's 5 units from X. So if I picture that circle, I'm going to go out 5 units as my radius, and then just kind of roughly sketch something like this, okay? And then same idea for Y. We know the epicenter was 13 units from point Y. So then if we draw a circle that has a radius of 13 and a center at point Y, it's going to be roughly something like this. Whoops, maybe not quite that. Okay, that's part of the circle. And then for Z, the epicenter was 10 units from point Z, so we would have a circle with center Z and a radius of 10. So if we go 10 units, that's going to be something like that. Okay, so our goal is to find that epicenter, and it looks like from our sketch that maybe, just maybe, there's a point of intersection of all 3 of those circles right about there. So our goal is going to be to find that point of intersection. So suppose I write the equations of the circles. So for the red circle, it would be x minus 7 quantity squared plus y minus 4 quantity squared equals 25. And for the blue circle, it would be x plus 9 quantity squared plus y plus 4 quantity squared equals 169. And then for the green circle, we would have x plus 3 quantity squared plus y minus 9 quantity squared is equal to 100. Okay, so we're looking for the point of intersection of these 3. Okay, so what we're trying to do then is find the point of intersection of these 3 curves. So there's a lot of algebra ahead, and what I'm going to do next is I'm going to multiply each equation out so that it doesn't have parentheses anymore. So the first one is going to be x squared minus 14x plus 49 plus y squared minus 8y plus 16 equals 25. The second one is going to be x squared plus 18x plus 81 plus y squared plus 8y plus 16 equals 169. And then, treating this like a system of equations, we can go ahead and subtract these 2 equations, and that's going to cancel the x squared terms and the y squared terms. And that's going to give us negative 32x minus 32 minus 18y equals negative 144. Let's multiply both sides of this by negative 1. So we have 32x plus 32 plus 16y equals 144. Let's subtract 32 from both sides. So 32x plus 16y equals 112. And then we can divide both sides of the equation by 16, and we get 2x plus y equals 7. So I'm going to call that equation A. Now I'm going to go back to equation 3. We'll go ahead and number these. And let's multiply equation 3 out. Put it over here. So that gives us x squared plus 6x plus 9 plus y squared minus 18y plus 81 equals 100. We'll squeeze that in there. And let's go ahead and combine that with one of our other equations. How about equation 1? So we have x squared minus 14x plus 49 plus y squared minus 8y plus 16 equals 25. And if we subtract those equations, we will have 20x minus 40 minus 10y plus 65 equals 75. So we get 20x minus 40 let's go ahead and combine like terms. 20x minus 10x, or minus 10y, excuse me, plus 25 equals 75. So we have 20x minus 10y equals 50. And if we divide both sides of that by 10, we have 2x minus y equals 5. So let's call that equation B. So now let's take equations A and B and add them together. 2x plus y equals 7. 2x minus y equals 5. So that gives us 4x equals 12. So x equals 3. Okay, now if x equals 3, let's find y. So we have 2 times x plus y equals 7. 6 plus y equals 7, so y is 1. So that means the epicenter of the earthquake is a point 31. Now let's look back at the graph and see if that seems reasonable. That does seem reasonable, I would say, for that intersection point right there.